Hello class, welcome back to the dojo. My name is Jacob, or the Number Ninja, or Sensei. And this time around we're actually going to be covering square roots and cube roots. Last video we talked about integer operations. This topic is, a little bit different. It's not really related, but soon enough we're going to be using both of these ideas together. So it's important that we learn the cube roots and the square roots. That way we can do more advanced operations. So yeah, without further ado, let's jump right into the lesson. All right, square and cube roots. So what exactly is a square root? It's something like this. If you ever see this symbol, this is a square root. If you ever see that symbol, go with a little 3 here, that is a cubic root. And it just kind of changes the operation that we're doing. But what a square root is basically looking for is, let's say we have a square root of 4. We are looking for what number, if we get 2 of them and multiply them together, gets us 4. So in this case, it's actually going to be 2 times 2 is equal to 4, which means taking the square root of 4 will give us a 2. We'll do a few more examples just to kind of get it in your head, because it's counterintuitive at first. A cube root is the same idea, but one step further. Instead of looking for 2 of the number, we're looking for 3 of the same number multiplying to a value. So to continue the example from earlier, the cube root of 8, well, what number, if we combine 3 of them in multiplication, gets us 8? It's 2, by the way. 2 times 2 times 2 is 8. And how can we double check that? Well, we know 2 times 2 is 4. And then 4 times 2, gets us 8. So therefore, the cube root of 8 is 2. Now these are called perfect squares, the 4, and I guess this would be a perfect cube, the 8, because we can actually find a value where that happens. There are plenty of documents online that you can find that will give you a list of the most common perfect squares, usually from 1 through 12. We're not really going to do that here. Just know you can find it quite easily. But let's do a few more examples and show you guys how to think about this, because sometimes larger numbers will come up and they're hard to remember off the top of your head necessarily. So we just did the square root of 4 is 2, right? The next one that we can think about is every integer will have a perfect square, right? Because we just multiply it by itself. So the next one would have to be 3. Well, how do we know what that would end up being? What's 3 times 3? Oh, it's 9. So a lot of times it's actually easier to work backwards on these. I know that's kind of silly, but it is what it is. So just as another example, let's do the square root of 64. This one is a little bit less obvious. It's a bigger number, so it'll probably be a larger value, right? Let's try the next one that would have normally been, would be 4 times 4. That would only be 16. So let's try a larger jump then, right? 7 times 7. 49, if we remember our multiplication tables. Closer, but not quite there. So now let's try the last one, which, just a heads up, I know is 64. So therefore, the square root of 64 is 8. When we take square roots like this, we're actually getting rational numbers out of the answer because they're perfect squares. However, a lot of times we'll get something like the square root of 24, which, as much as we want to try this, we won't get anything. Okay, 4 times 4 was 16. That was too small. The next perfect square would be 5 times 5. That's 25, which is too many. So there's no perfect squares in the middle of these two values because, remember, we need a whole number for that to happen. Which means there's no such thing as a perfect square, or 24 is not a perfect square. So we will not actually get a rational number from this. I'll plug it into a calculator really quick just so we see what it is. But for our purposes now, yeah, you see it's 4.89897, and then it goes on forever. And if you notice, that's not a pattern, right? Because it looked like it was a pattern, but then changed to a 7. So this is an irrational number, which is what we talked about earlier. It's not rational, it's irrational. And again, not something we like. We're going to talk about how to actually handle these later on, but we definitely prefer rational numbers because they're a lot easier to use. A rule of thumb: if something in the square root is not a perfect square, it is an irrational number. So let me give you one more to try here. If you looked up the document that has all of the perfect squares, this won't be bad. But let me give you one example here to try as well. Let's try to find the square root of 81. So again, if you want to try this on your own, take a second to pause it here and figure it out if you can. I highly recommend that. All right, hopefully you guys were able to solve it. If not, no big deal, we're going to talk about it now. So we're going to use that principle from before, where if this is a perfect square, it will have been, one number that is a whole number, then the next number, then the next number. Those are the only way to get perfect squares. So beforehand, we got that 8 times 8 was 64. That was too small, right? That's smaller than 81. So we then want to try the next whole number. I guess I should say integer, because we talked about that earlier. You see, definitions are important. The next integer, it's also the next whole number, never mind. But the next integer is 9. 9 times 9, let me remember my multiplication table. Oh, that's 81. Wait a minute. That means our square root is 9. The square root of 81 is 9. This is rational, and 81 is a perfect square. But this is a very powerful concept, right? You will only get perfect squares using integers. So if you're trying to find what a perfect square is, just start multiplying integers together. If you're too small, go up a number. If you're too big, go down a number. Where this is also helpful is approximating values that are not perfect squares. Obviously, there's calculators that can give you the exact number, and there are concepts that we'll cover that will show you how to keep them as square roots, but simplify them. But for now, let's say we have something like the square root of 32. I'm going to let you know now this is not a perfect square, okay? But we can try to approximate its value by finding the perfect squares on either side of it. So one that we might remember from earlier, let me just scroll down a little bit, is that 4 times 4 is 16. Wait, sorry, we actually went a little bit higher, so let me just go a little bit higher. Well, remember that 5 times 5 is 25, which is not the value we're looking for, right? We're looking for 32, but it's pretty close. So we're just trying to bookend it, find the closest perfect square on either side. Which means next we want to try 6 times 6, right? Using the same concepts we just talked about of finding perfect squares. 6 times 6, well, that's 36. Now we have the number right above it and the number right below it. And we know this because there are no perfect squares in the middle, because 5 and then the next integer is 6. Which means we don't know exactly what the square root of 32 is, but it is going to be approximately, this is the approximately, the little squiggly one, approximately 5 point something, right? Exactly what, we don't know. This one is closer to 36 than 25, so it's probably like 5.7, but you can probably get away with just saying approximately 5. For fun, if I plug this into the calculator, oh, I was off by a little bit. It's actually 5.65685, and then again, repeats forever because it's irrational. So that's a very powerful idea on how to approximate square roots. This is helpful if your teacher ever asks you to like order numbers. I know that's a common thing early on in pre-algebra, and they'll give you like a whole number, an integer, a fraction, a decimal, but then also a square root. This is how you can approximate that value and get an idea of where it should be on your number line. So what else we want to talk about here? Let's see. Cube roots. I forgot to talk about cube roots. Cube roots are the same idea. Everything I just talked about applies to a cube root. But now we're looking for a number times itself 3 times instead of twice, right? So 2 times 2 times 2 is 8. Also, I guess we should mention 1 times 1 times 1 is 1. This is also a perfect cube. And if you think about it, the same thing would apply for squares, because 1 times 1 is 1. And you can do this for every type of root. 1 to whatever would always be 1. But the same idea applies, right? If we want to find the next perfect cube, we just go to the next integer and we multiply it by itself 3 times. So 3 times 3 is 9. times another 3 is 27. And again, we can do the same thing with approximating. We can do the same thing with cube roots. But I know it's a little bit harder to think about cube roots, so let's try an example or two here. We will know it's a cube root because there will be a 3 in our root symbol. And let's try, see, now I have to think about one. The more annoying thing about cube roots is they get much larger as well. So let's try 125. This is obviously super large, so we're going to, or it looks super large. When you get it familiar, you'll realize you're not, but we'll try something here. Let's just pick a number and let's try it, right? So 3 was too small. Let's try 7. So 7 times 7 times 7. 7 times 7 is 49. If we do another 7 attached to that, and sometimes you are unfortunately going to have to do the scribbles like this here, right? 7 times 9 is 63. 7 times 4 is 28. Plus our 6 gets us 34. Okay, so 343 means we completely overshot. So we actually want to go in between 7 and 3 for this next one. And this is the idea, the thought process of how you want to do these. Obviously I know it, so we'll just jump ahead to what the correct one is. 5 times 5 times 5. 5 times 5 is 25. And if we then do 25 times 5, 5 times 5 is 25, we just talked about that. 5 times 10 is 10, plus 2 is 12. So that's 125. So the cube root of 125 is 5. These ones, again, are more annoying because the numbers get bigger a lot faster, but it's mostly the same exact concepts as square roots. So like I was saying, let's do an example here. A cube root, let's try 64. So I don't want to give you guys one too big, but let's just see if you can do that. Again, pause it here and try to solve it. I highly recommend it. All right. So hopefully you remembered from before that 3 times 3 times 3 is 27. And then you also remember that we did 5 times 5 times 5 and got 125, which means we're in between these. And there's only one integer in between them. So without even checking, we can say it's 4. Because remember, to be a perfect square or a perfect cube, got to come from an integer. But if we wanted to do it ourselves, 4 times 4 times 4, the first one would get us 16. And then 16 times another 4. 6 times 4 is 24. 4 times 1 is 4. Plus the 2 gets us 64. So yeah, hopefully that wasn't too bad. That's the basics of square roots and cube roots. There's a lot of things you can do with these, like combining them with integer operations and using them to do things like area and volume. But we'll probably talk about that next time. If you guys have any questions, again, please feel free to put them in the comments. I'll see if I can answer them for you. Obviously, depending on how complicated they are, I might not be able to. But yeah, hopefully that was a good lesson. And hopefully you guys are willing to take on this journey with me and continue to train in my dojo, learn about pre-algebra. And by the end of it, you guys might even earn a black belt. I'm working on figuring out how to do a thing. But obviously, you know, the whole thing with belts is you've got your white belt, your yellow belt, your orange belt, etc. You guys are at white belt right now, but I'm going to help you guys train yourselves up to a black belt, and hopefully you'll feel like you've mastered algebra or pre-algebra by the time we're done. So yeah, good luck on all your homework and your tests and stuff like that. And I'll see you guys next time.